Alright, welcome to another video of chemistry. This is continuing our oxidation reduction reactions. This is part 2, and we're taking a closer look at these reactions and what's actually happening at the atomic level. So some redox reactions are more apparent than others. For example, here we have a chemical equation. We have zinc solid, copper sulfate aqueous, and then we have a reaction that occurs, and then we end up with, on a product side, zinc sulfate aqueous with copper solid. Alright, so let's take a close look at what's happening in this chemical equation. So like I mentioned before, we have first zinc, and it's in a solid state. Okay, for our lab, we'll have a strip of zinc, a metal strip, that we will put into a container containing copper 2 sulfate aqueous. You'll notice that this aqueous solution has a blue hue to it. Copper, when I mention copper, you're probably thinking of a brownish gold wire that is commonly used in electric wires. Well, copper, when it's in an aqueous state, when you strip a couple of its electrons, it actually has a bluish hue to it when it's mixed with water. So when light bounces off the molecule or the atom copper, the ion copper, it bounces back the color blue. Okay, so let's continue. So on the reactant side, you'll notice that zinc and copper are two metals, right? And you'll notice that on the product side, they switch places. Okay, copper now goes from being aqueous to a solid state, and zinc goes from being into a solid state to an aqueous state. So let's take a closer look at what actually is happening in this reaction. So we're going to insert our zinc metal into a copper solution. Okay, now pay close attention to what happens. Two things, okay? Two things that we're going to look at. But let's just zoom in a little bit more and look at the atoms and how they're behaving. All right, so like I said before, copper 2 sulfate. So this is an aqueous solution. Copper is in an aqueous state and it floats around. So there's millions and millions of copper ions just floating in this liquid, which gives off that blue color. And these copper ions, they're missing two electrons. Two of the electrons are missing, hence you have that +2 charge, okay? Now mixed in with this also you have sulfate. And sulfate has two extra electrons, so you have, or actually this sulfate polyatomic ion has two electrons, or has a -2 charge, and we'll talk about polyatomic ions in a later video. Okay, now notice with the sulfate, sulfate on the reactant side is an aqueous state, and then sulfate on the product side is still in an aqueous state. If you go back to our previous video, something that does not change states in a reaction is considered a spectator ion, right? So sulfate is a spectator ion, so we're not going to actually have it in our diagram here because, well, it doesn't react, so we'll just leave it out for now. So our copper 2 ions are floating around, and then when we insert our zinc metal, and that zinc metal is technically made out of millions and millions of zinc atoms. Okay, now notice zinc has no charge, it's neutral, so it's in a solid state, it's in its normal metal state. Now something funny happens when copper gets closer to, or it comes in contact with the zinc. That copper ion, that +2 ion, is going to attract, okay, it's going to attract two electrons that it needs from zinc. Okay, so notice what happens to the zinc right over here when this copper comes in contact with it. Okay, notice what happens to these electrons. Those electrons from zinc are now going to be attracted to copper, and now zinc is missing two electrons, so it becomes a +2 ion. And you'll notice that copper loses that +2 charge and it now gains a neutral charge, and it goes from being an aqueous state into now a solid state. And zinc goes from being in a solid state now being an aqueous state. So they essentially switch places, and the reason why they're able to do that is because copper is able to attract the electrons from zinc. Okay, so again, this is happening all the time where more and more copper ions that are floating around will come in contact with the zinc, and they will strip two electrons. Notice what happens to the charges. They switch. And now zinc, because it's missing two electrons, goes from a solid to a aqueous, and copper goes from being aqueous to a solid. Okay, so they're switching places. And this happens millions and times over in this reaction. Now, another thing I want you to pay attention to that I was leading to in just a minute ago, pay attention to the color of the solution. The solution started off with a blue hue, but notice what happens as more and more copper ions become copper solid. That blue color starts becoming more clear. Okay, as more and more copper ions are being converted to solid, okay, the color of the liquid of the solution becomes more clear, because remember, the reason why the solution was blue was because of the copper ions that were floating around in the water in the solution. All right, so let's look again at this equation, but now we're going to look at it as a complete ionic equation. So this is a more accurate representation of what's actually happening in this equation, right? Okay, so we have our zinc solid, and then we have our copper aqueous separated from our sulfate aqueous, and then our copper solid and our zinc aqueous with our sulfate aqueous. All right, so notice what happens with copper. I go from being an aqueous solution with a positive 2 charge to going and becoming a solid. And that plus 2 charge is now gone. It's gone because, if hopefully you remember, uh, copper gained 2 electrons from zinc, right? And so zinc now will be missing 2 electrons, and you'll notice that it will become a positive 2 charge. And it goes from being a solid to an aqueous. Yes? All right, so let's revisit the experiment once again. So notice our zinc goes into our copper sulfate solution, right? And what happens to our zinc? You're going to notice that it's going to get covered. A coat of copper will coat it. And that's the copper ions that are replacing the zinc ions. And then notice again what's happening to the solution. It's going from being a dark blue to a lighter blue. And that's because it's losing its copper ions to become copper solid. Okay? So two things to notice. Number one, the copper aqueous turns into copper solid. So that's that coat of copper that you see coating the zinc metal rod. And then number two, the copper aqueous turns to a lighter blue, and that's because the ions are being converted from an aqueous state to a solid state. All right, so here's a look at that reaction once again, or that chemical equation. All right, let's take a look at another example here. Here I have copper solid. So this time I'm starting off with a copper solid, and I'm going to dip it into a silver nitrate solution, which is an aqueous. And then I'm going to have a reaction occur, and I'll end up with a copper nitrate with a silver solid ion, or just a silver solid, really. All right, so let's see what happens here. So now notice that this solution this time is clear, okay? So in here there is silver and nitrate. Again, this in a laboratory will look just like water. So again, this is why you never drink anything in the lab, because even though this looks like water, there's actually silver nitrate ions floating around here. Okay, so something that may look harmless can actually be very dangerous. Okay, all right, so let's see what happens when I put copper solid inside. And then notice these two things. The same two things that you were asked you to notice before, I want you to do again. Notice the change in color, and also notice if there's a coat that begins to form here on the copper rod. Okay, so I dip it in, I wait a couple of minutes, and I'll begin to notice that there's a silver coat that builds up. And secondly, you'll notice that the solution will begin to have a blue hue to it. Okay, and as more time goes on, it'll get darker. All right, so let's take a closer look at what's happening. And remember, copper has a blue color when it becomes aqueous. So I begin with the silver nitrate, right? And of course I have the nitrates floating around, but these are spectator ions. So just to make this a little cleaner and less convoluted and busy, I'm going to take away our nitrate ions because they don't react. They're spectator ions. And I'm going to dip in my copper. All right, so now that I have my copper in here, you're going to notice silver coming in contact. Take a look down here. Silver is going to come in contact with our copper. And notice what happens to the charges. Okay, 2 electrons from copper will be attracted to silver. And now the plus 2 charge will go to copper, because now copper has lost 2 negative charges. So it has now a positive 2 charge. Now that it has a positive 2 charge and it's losing electrons, it will go from being a solid to being now aqueous. And then the silver will go from being aqueous to a solid. Okay? And then notice up here we're going to have more silver ions come in contact with our copper solid. And it strips electrons, and you exchange charges, and you exchange states from copper solid to copper aqueous, and silver aqueous to silver solid. Okay, and take notice again that the color of the solution is changing to a more darker blue as more copper ions are being released into this solution. So here we go again, taking a look at the chemical equation. Okay, copper solid with silver nitrate aqueous, and notice what happens to the copper. Okay, so the complete ionic equation. Okay, well, let's look at the silver first then. So notice the silver on the reactant side, I have a +2 charge. Okay, and in this reaction, it will steal 2 electrons from copper. So it will go from being aqueous to, on the product side, becoming a solid state, right? And now notice what happens to copper. Copper goes from being a solid, okay, 2 electrons are taken away from silver, or to silver, and then copper solid becomes copper aqueous, +2 charge, as it loses its electrons to silver. All right, well, that does it. That does it for the 2 examples I wanted to show you for oxidation reduction reactions. In lab, you're going to see several of these, so good luck in your studying.